On the morning of December the 1st, 1924, Fritz Angerstein decided, for reasons that remain unclear, to murder 8 people with a mixture of knives, guns, and axes. Afterwards, he stabbed himself and claimed to have bravely fought off the gang who killed everyone else. Though in court, he later confessed after someone found 2 images of the crime, showing him murdering people with an axe, an occurrence that rather undermined his legal defense. What makes this unusual is that these incriminating images were allegedly discovered burned into the retinas of 2 of his victims at the moment of their deaths. You've probably heard the belief that the eye retains the last thing it sees before death, but dismissed it as a superstition with no scientific basis. And you were wrong. Sight is possible due to the rod and cone cells of the retina. The cone cells contain one of 3 different types of pigments called opsins that are sensitive to either red, green, or blue. Cone cells are responsible for the perception of color and fine detail. The rod cells, which outnumber the cone cells 20 to 1, contain a substance called rhodopsin, or visual purple. This is much more sensitive to light and is responsible for night vision. When exposed to light, these chemicals bleach or break down into a form of vitamin A. This causes a change in the cell's biochemistry, altering the electrical charge on the cell membrane and the flow of the neurotransmitter glutamate. This is detected by nearby cells designed for this purpose, and ultimately passed on to the optic nerve. This process is known as visual phototransduction. The important thing to note here is that the process of seeing uses up these chemicals, and so the cells have to continuously make more. A bright enough flash can bleach almost all the pigments in your eye at once, leaving you completely blind until more can be made. It happens in normal sight too. Right now, the parts of your retinas showing you white things contain less pigments than the parts showing you black things. So, at the moment of death, when the cells die and lose their ability to regenerate their supply, the last pattern of light seen is frozen in the pattern of pigments in the dead retina. Of course, if you die with your eyes open, the light rushing in will soon completely bleach everything, overexposing and destroying the image. But if you close your eyes at the moment of death, the image can be preserved. If only there was some way to develop the retina like a photograph. A way to develop the retina like a photograph was discovered by the German physiologist Wilhelm Kuhner in the 1870s. He discovered that alum, a whitish chemical that was a favorite of the ancient alchemists, had the property of staining rhodopsin. So, in a bath of dissolved alum, the last image seen by a retina could be fixed like a photographic negative. He then experimented with various animals, showing them something, then decapitating them, peeling off their retinas, and developing them to see if he could obtain a clear image. He did. This is the window in Kuhner's laboratory. It is also the last thing ever seen by a small rabbit. But Kuhner didn't want to stop there. He obtained the freshly guillotined head of a murderer and tried to repeat the process on him. But the results were disappointing. The image was blurry and only featured a single irregular whitish shape. While the image itself no longer survives, Kuhne drew the outline of the shape in one of his papers. Others have noted that the deceased had been blindfolded at the time of his execution, and speculated that this shape, which looks rather like a guillotine blade, might represent his last sight of the instrument of his imminent demise. This relative failure aside, this process, now christened optography, was seized on as a possible forensic technique. Goaded on by the press, police tried to utilize it to solve a number of high-profile murders, including the Jack the Ripper killings. The only case in which it was claimed to be particularly useful was that of Fritz Angerfield, but it's now believed that optography was probably never used, and the police made this detail up to get him to confess. Later, after hundreds of experiments, Kuhne and his assistant, Ayres, finally concluded that the images obtained were highly unlikely to ever be useful in crime fighting. But then, in 1975, almost a century after the initial experiments, someone high up in the German police heard about this technique and contacted scientists at the local university to see if modern technology could help improve on Kuhne's results. The resulting project was led by Dr. Evangelos Alexandridis and experimented again on rabbits using different techniques. While they were able to obtain general patterns and even readable numbers, repeated attempts at capturing a portrait of Salvador Dali were almost completely unsuccessful. They eventually agreed with the earlier experimenters that forensic-grade images could simply not be obtained by optography. Today, recent developments such as scanning laser ophthalmoscopy would doubtless hugely improve the quality of images, but people have lost interest in optography as a forensic technique. So, on your next killing spree, be wary of security cameras, fingerprints, and DNA, but the eyes of your victims will likely keep their secrets to themselves.